I'm going to just do this as kind of a check into the sound quality to make sure that we are online. This presentation is going to be about electric lighting design and really going through the concepts and how to create a visually wonderful, comfortable environment for people and occupants within a space. We're going to go over some different concepts. First, just the whole, how do you light a space? What's important to light? And then we're going to get into specifics on equipment, especially with the new LED revolution, as I like to call it, on the differences between LED luminaires and what the standard equipment used to be. And then finally getting into lighting controls, into not only how that gives people a sense of control over their space, but also how you can save energy. We're going to start off with the importance of surface brightness. Too often people ignore surface brightness, and I'm going to show you some bad examples. Like for instance, in this picture, you can see everyone sitting down there probably is really bored. And of course, as a line designer, I look up and I go, I think it's the lighting is doing it to them. The overhead lighting is shining straight down, it's glaring. And if you look at the wall behind the people, you can see of how the dark shadows actually come down and almost perceptually lowers the ceiling in that. And in these two spaces, again done with really bad lighting, the retail space on the left, I'm pretty sure that they were thinking of putting up track lighting to accent the merchandise. But if you look, they put in the wrong bulbs. They put in floodlights instead of accent lights. So therefore, the light actually does not get down to the merchandise. And on the right, the entire space is kind of lit with decorative luminaires. It looks fine maybe during the daytime when the sun's out and the daylight's coming into the space. But if you look at the space at night, it's going to be really bright, glary lights. This particular space is way overlighted. It's almost as if whoever did the design or the layout just plunked in as many 2x4 lights as they could, flooding the space with light and using a lot of energy. Totally wasted light. And I'm going to kind of blame the design by the reflected ceiling plan, as I like to call it. It's a very terrible concept to do, and it's like putting all the lights into a pattern on the plan versus really understanding what the surfaces look like underneath. I'm going to kind of blame the mechanical engineer for starting this whole move towards the drop ceiling. I do understand that with ductwork, you could deliver air from one part of the building to another. And then, so these ducts are in the ceiling. The architect looks up and goes, oh, those ducts are ugly. And so they probably designed at that point the drop ceiling so they could get access to the ducts, and yet it's this plain drop ceiling across. Well, comes along the line designer, electrical engineer, say, great, I could put all my lights up into that drop ceiling. Thus, everyone's kind of fighting for space and design by reflected ceiling plan. But let's go back and look at really what our visual system is about. Thermally, I think our senses on air temperature, airflow, humidity, we really pick up on this very, very quickly. But unfortunately with lighting levels, uniformity, yeah, we may be sensitive to it. Glare is the one thing that we all will become sensitive to and saying that's what we need to address. Here is our beginning of electric light design. You always begin with daylight. Make sure that your daylight is beautifully designed and coming in with minimal glare. And then the electric lighting does not duplicate the day lighting, it supplements it. Instead of flooding your space with light, you turn around and go, what can I light? I'm going to light surfaces. I'm going to light the walls, the ceiling, and then I'm going to control the light so there's plenty of daylight coming in. I can dim the electric light or even turn it off to save energy. Here's an example of where the electric lighting is basically lighting the surfaces, mostly the ceiling here. And it's great because you can put any arrangement of furniture or activity down below. Because the ceiling is evenly lit, that this is not a problem at all. And this is probably the most effective way of doing electric lighting. I love this picture because on the left two slides, my daughter and I, we went to schools to look at where she wanted to go to college. And part of her journey was to go and look at the libraries to see of where she could study and what they were like. The two schools on the left are actually Ivy League schools, and I walked in, I went, oh, I can't believe how bad the lighting is in here. It's definitely designed by Reflected Ceiling Plan and a waste of light, especially for a library. And on the two pictures on the right, yes, we've got a little bit of electric light lighting the ceilings on the lower part of the ceilings, but daylight comes in and fills the space with light. So this is an example of where you really complement and you don't duplicate the electric light or the daylight. There are 3 types of lighting that you want to actually put into your space and start designing for. The first one is ambient lighting. That is the lighting that's going to fill the architecture and fill the space. Then task lighting, or we can call personalized lighting, will actually help and give people the type of lighting that they need. Accent lighting is just kind of a little bit of light to fill in the space and to add interest. In looking at different types of electric lighting design, the ambient lighting is probably the type of lighting that is misapplied more than anything else. These two spaces, the ambient lighting is trying to be kind of designed by Reflected Ceiling Plan, but they're trying to get one system to do it all, to be both ambient, task, and accent lighting. I feel sorry for, in the picture on the right, the poor gentleman. Probably the electric overhead lighting is actually shadowing what he's trying to do. These type of areas, you've got way too much light and it's using a lot of energy. If you start using ambient lighting that is indirectly lit and filling the space with light, mostly the ceiling, then you've got this beautiful arrangement, and look at it, can even be an eclectic design up above as long as the ceiling is lighted. This particular type of lighting system can use very, very little energy because you're not trying to get the light all the way down to the floor. And then, to me, I love it when the ambient lighting, you can't even see where it's coming from. That the one thing that you're celebrating is the architecture itself. To supplement the ambient lighting is task lighting. The picture on the right, there is task lighting, very simple system underneath the overhead cabinet. And on the left, you can see not only do we have under the overhead cabinet, but we have lighting that can be adjusted by the user to be turned from either side or another depending on what the user is doing. And here are just some fun concepts of what you can do with electric lighting. And the luminaire on the right, kind of on a little stand, it can tilt, it can turn, it can do anything you want, and it can even dim. This particular task light is actually an occupancy sensor. So if you're not around and you accidentally left it on, it will turn off. Exit lighting, this is just kind of fun, little key things to do either in a hallway or if you want kind of an introduction into an area, adding interest. It can be non-uniform, but you don't use a lot of exit lighting. It's used sparingly in a space. So luminaires have really taken off, and these are what we call lighting fixtures. The terminology is luminaire. And with LED luminaires and solid state lighting, they really have changed the way that we're doing design. Here's just an example of what you can do with LEDs. You can actually hide the system. And if you look, there is no design by reflected ceiling plan. Nothing's in the overhead area. All we're lighting are the walls and even some area lighting underneath the benches. And boy, has it been a lighting evolution. From Edison's incandescent lamp that basically was kind of like a filament that was heated up and put out most heat and a little bit of light, to the compact fluorescent that was a great start in how to light, how to be energy efficient. It was kind of a blob of light. Compact fluorescent, good idea to save energy, but it really didn't take off. And then finally, we went to the LED light bulb, which is great because we could dim it, it had warmer colors, and we could get it directional. The light source is kind of light source of the futures on the far right, and that's called an organic LED. And it can bend, you can put any shape. It's really one of the most amazing light sources that we will be seeing in the future. Here's an example of where we actually designed with the organic LED or the OLED, and we were able to do different patterns, kind of play with the light in a space. But again, with LEDs or solid state technology, there's so much more that you can do than what we could have done with the fluorescent lighting technology. We can change the color of light, which we're going to show you some examples. Here on the right are kind of the traditional light sources that we're used to, and now we're changing all of those into solid state light sources. Instead of ballasts, we need drivers. Drivers just kind of look at the voltage and to convert it from an AC voltage down to DC and a very low voltage. Also with solid state lighting, we can easily shield and do a whole bunch of different things and dimmability that we couldn't do with the fluorescent or the metal halides or high pressure sodiums. Here's what the traditional equipment looked like, and it was mostly designed for the 4-foot fluorescent tube. My challenge to all of you is to go, what designs can we do? We no longer need that shape. And yet if you look at the luminaires still on the market, they're kind of mimicking the fluorescent light bulb. This was a really interesting study done by the California Energy Commission, where they looked at the differences in classrooms between direct lighting or putting the light up on the ceiling. Because putting the light up in the ceiling is more pleasant and fills the space with light, that the students actually perceived that it had more light. And as a result, they're able to more than half the energy per square foot in a space by just changing concepts. And architectural solid state lighting, notice even in addition to lighting the columns and underneath the benches, that you can light the ceilings in coves. And in this particular design, every single light source is hidden and is kind of tucked away into the architecture. So ambient lighting, we can do a lot more with it with solid state lighting. And you can get very small apertures and to spread the light. Solid state lighting, LEDs can actually go a long distance. That's something that the compact fluorescent or fluorescent lighting technology could not do. Also, we can dim these lights, the LEDs, down to very, very low dimming range. It's now down to 0.1% dimming range. These luminaires are really, really unique. The LEDs are actually in the housing, in that metal part around, and they shine through what we call a light guide or a light wave. It's a film that distributes the light evenly, as you can see in the picture on the right. It sends the light up to the ceiling and then down. But when the lights are turned off, you can see through these lights. If you had an overhead daylighting system, it would allow daylight to come through and not have a big, huge metal box that was preventing the daylight from shining through. For your class projects, you may need to go and select electric lighting luminaires. And I just put down 4 companies that really have a huge variety of really excellent solid state lighting luminaires. So I would encourage you to go to these websites and select luminaires first that are going to light the walls, graze the walls, and then light the ceiling. And then also look for some task lighting. And finally, we need controls. Just to look at controlling this space and how we can tie the electric lighting into the controls, not only automatically, but giving people personalized control of their space. These are some automatic devices that as you walk into a space, the lights are either going to turn on and off if you forget to turn them off, or they're going to dim when there's plenty of daylight. There's a big difference between occupancy sensors and vacancy sensors. Occupancy sensors turn the lights on when you walk off in a room, and they turn them off. You don't have a choice. I prefer vacancy sensors where when I walk into a space, I have to physically turn the lights on. I can also turn them off when I leave the space, but if I forget, they will turn off. When you're beginning your design, please start with daylight. Make sure that you've got the daylight well designed and that you don't have the glare coming in from the windows. You have great shading devices on your daylight windows and your view windows. And then get the electric lighting to go up to the ceiling or to the walls and dim the lighting according to how much daylight is coming into the space. Having control over your lighting is probably the highest occupant satisfaction rating, to be able to dim the lights when you have got control. Also, occupants really like indirect lighting. In occupant satisfaction surveys, indirect lighting rates so much higher than anything else. And here's an example of a survey that was done by the Light-Right Consortium. And they looked at just if a space only had downlights, aka designed by a reflected ceiling plan. And the occupant satisfaction was in the 70 percentile range. If you changed that lighting system to direct indirect lighting with wall washing, the whole satisfaction went up at least 10%. And then you add that the occupant has dimming control, you get another 5 to 10% on your occupant satisfaction. So it's the final one, direct indirect lighting with wall washing, and the occupant gets to control the situation. And if you look at just when you're doing your return on investment or your energy calculations, you can start, what is the percentage that a space is occupied? And you can see that, yeah, on weekends, not many people are in there. During the week, it is. But what a lot of people forget is that cleaning crews come in many times in the evening. And if you don't have a way of turning off the lights automatically when a cleaning crew leaves, that many times you'll look at buildings and you'll see a lot of lights on in the middle of the night. Here's again just information for some energy modeling, that what the percent reduction that you will get in energy by putting in occupancy sensors. And it's the rooms that are rarely used or they don't have a lot of occupancy, like a locker room, that you get the highest percentage of savings. And then here's another study just to look at, if you've got daylight sensing or occupancy sensing, what are the multiple types and the type of potential that you could have for lighting controls in actual situations. Yet another study that kind of looked at, what if I had an occupancy sensor that was automatic off, but it had a huge delay, a 20-minute delay? What, am I really saving a lot of energy? And especially in the private office or with the conference room, you're not saving nearly as much as if you lower that delay. And so this is where it's really good. And the automatic sweep off, which is the bottom one, that again is to help when you know what the cleaning crew schedule is and to make sure all the lights are off in the middle of the night. So there's a huge impact in energy savings. And what we can see is, if we design with daylight, we can do our ambient task line design combination. And by doing it well and not letting the ambient do everything, but to separate the two, we can get a 30% reduction in energy. You add on top of that intelligent controls, which are occupancy sensors and daylight dimming, and even tying into the building automation system. And then, wow, add employee productivity, and you've got, towards your zero net energy buildings, you've got 80 to 90% energy reduction. So I'll stop here, and I just wanted to know if you've got any questions. And if you do, please feel free to email me at Nancy Client and Associates, and I'd be happy to answer your questions. Thanks again.